if I were to ask you to draw a graph, right? Let's say position versus time. I gave you data. What would you do first? Rocco.
Draw the graph lines.
Okay, so you mean axes?
Yeah.
Sweet. Okay. So something like this. Oh, but you would do so much better than that, right? Because you would use a straight edge. Okay, what would I do next? Matthew.
Label the axes.
Label the axes. What am I going to label them?
Position is your y-axis and then time is your x-axis.
Okay, position. And what would I write here in parentheses? Meters, because that's the unit. And then I would have time with S on the x-axis. Time's always on the x-axis. Okay? Yes, sir.
What's the next thing you can do the graph points?
Okay.
Or
I would like,
it.
would anybody like a title?
Isn't that the first thing you do?
I mean, whatever. When I'm grading it, I don't know the order in which you put the things on the paper, so we're good, right? So, but let's just make sure it's there. So we would write position versus time. Okay, so now when I'm looking to put numbers down, what kinds of things am I thinking about? Spacing. I want to think about the best spacing I can get. So one of the things that you want is you want to make sure to stretch out your axes as much as possible, right? But still keeping on the page. So usually that ends up being like making sure that your x-axis is as stretched out as it can be, right? And so you might think about how you want to space it. So if I put my 1 here, and my 2 here, and my 3 here, how much are each of those lines worth?
1.5.
Half, okay? What if I did it 3 spacings? Not 0.75. They're a third each, right? So like 0.33, right? 0.33 and 0.67, right? That's how you would write those for a third. Yes? Vigorous nods? Yes? Excellent. What if I did it 1, 2, 3, 4, 5? Just kidding. I can't count. 1, 2, 3, 4. You can't see. Sorry. Then they're each 0.25. So it would be 0.25, 0.5, 0.75. Those are important for you to know the spacings so that you can you can plot your points correctly, and when you're picking your points from your best fit line, that you can read the coordinates well, right? Those are important to know. Let's do one more. What if I did 1, 2, 3, 4, 5? What are they? 0.2. Okay. If I did 6, what do you think? That's like not a really useful number, is it? Do you know like the multiples of 1/6 in your head? I don't. How about 1/7? No. How about 1/8? 1/9? So honestly, when you're looking at your spacings, if you can space it more than 1, right? Just like 1, 1, 1, 1, then you would do, halves, a thirds, a quarters, or a fifths, right? So that fifth would be 0.2. So that would be sort of where you're going there. You wouldn't want to do a really complicated spacing. Okay? Fantastic. So let's keep this like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 5. All right, so I'm just going to make up some numbers. Let's say my y-axis, I'm just doing it by ones, okay? But do I want to write every one? Probably not. That's not fun. But I could make it look nice if I just wrote 1, 2, 3, 4, 5. 1, 2, 3, 4, right? And then that's 10. Does that make sense? Okay? So then let's say I carefully plotted my data. I spent so much time looking at it, more than I just did. And then I should do what after I've plotted my data correctly? I need to draw a line of best fit. So, oh gosh, that's pretty. Okay, so now what? Calculate. How do I calculate? Find points, yes. Do I use data points for my slope calculation? No, boo. No data points, okay? We want to find gorgeous, easy to read points. So we're going to look along here and say, ooh, look at that. Yay, that's going gorgeous. And then I'm just going to keep, oh, look, there's another one. Nice. Okay, so now I have to read those points off the graph, right? So I need to look at my coordinates. And what is it? Can you guys tell me what they are? You can't see. I'm sorry.
1.33.
What is the spacing?
Oh, no, that's not 1.2.
It's 1.2. And what's the y?
4.
It's 4. And you'll notice I put the units in. 1.2 seconds and 4 meters. You're not required to put the units in your ordered pairs. However, I did see some issues when people were calculating their slope. They got themselves confuzzled and were like subtracting a distance from a time, right? But if you have your units next to your numbers, then that'll help alleviate that, right? You'll be less likely to make those mistakes. Okay? All right. And what's the other point that I did? 2 seconds and 6 meters, right? All right, so now when I calculate my slope, it's going to be delta what over delta what? So delta what? Delta x over delta t, because it's rise over run. And in this case, my vertical axis, my rise, right, is position. So it's x. So delta x over delta t. Do you know what that's going to be? Like physical quantity? Velocity. Nice job. That's going to be velocity. All right, and now we go 6 meters minus 4 meters on top. And then 2 seconds minus 1.2 seconds. I know what 6 minus 4 is. Who's impressed? All right. Thank you. And then 2 minus 1.2, I also know, is 0.8. Now, am I confident enough to do 2 divided by 0.8 in my head, even though I'm pretty sure that it's 2.5? It is 2.5. And the units are meters per second. Yeah? How do you feel about all of that? Do you think you understand all the different things I'm looking for? Because that's a lot of different things that you're supposed to do. And all of those things that we just discussed have points associated with them. Okay? So, this is probably one of the hardest concepts, even maybe the whole year, that we've talked about. And that's that little chart with the V and the A, positive, 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 negative, negative, positive, negative, negative. Okay? So, what I want you to think about, right, is if the velocity is positive, which way is that supposed to go? So I think in the packet it said to the right. Yeah?
Yes.
Okay. And then the negative ones to the left, right? But if we're looking at these graphs, right, it would look like this, and then what did it look like next? This and that, I think, right? Okay. So if I'm talking about a positive velocity, and my velocity is on the y-axis, where am I going to find positive velocities? On the positive side, so at the top, right? So these top 2 graphs are both positive velocity. Do you see that? And the bottom 2 graphs have negative velocity numbers. So you know that the top's going to be 1 or 2, and the bottom's going to be 3 or 4, right, from the packet. Okay. So let's look at the top one. Sorry, the top left one. So I am moving in a positive direction. And what else do you see from that graph? How do you know I'm speeding up? Okay. Okay. And I know that because my positive velocity is getting more positive. Okay? So this one was number 1 because that was the speeding up. And what is acceleration? If you look at a velocity time graph, how can you tell about the acceleration from a velocity time graph? Yeah? Yes, it's the slope. So this slope right here Is that positive or negative slope? That's a positive slope. So there it is. Positive velocity, positive acceleration, which means positive slope. That's graph number 1. Okay? Look at graph number 2. Well, we now know this is 2, right? It's a positive velocity and a negative slope. Okay? When you think about positives and negatives, sometimes it's nice to think about a number line, right? So if I have, so here's a 0, okay? And actually, maybe I'm going to do this like in person to you. So I'm at 0 right now. Point to the positive side. Right? So thank you, 3 of you. Anybody else? Good morning. Point to the positive numbers. I'm 0. Number, that way. Okay, cool. Point to the negative numbers. There you go. All right. If I am moving in a positive direction and I am getting more and more positive, I'm speeding up that way, right? If I am going in a negative direction and getting more and more negative, then I'm speeding up. So this negative, oops, just kidding, wrong one. Okay. This one, okay, it's negative, but it's getting more and more negative. And that still has a negative slope. So it all goes together. Hi, how's it going? Okay, and then this last one, it is negative, but it's getting more positive. So it's like I'm going this way, but I'm getting more positive. I'm going back to 0. I'm slowing down, right? If I'm positive and I get more negative, I'm going back to 0 and I'm slowing down. So here's the thing, guys. This is one of the hardest concepts, and I'm talking about it at a reasonably high level. If you don't totally get it, it's okay. Don't beat yourself up, okay? This is hard, but hopefully some of it's starting to click somewhere in there, okay? Awesome. So in the packet, you did something with a velocity time that looked like that, right? And it asked you for the position time and acceleration and time, right? So what were your thoughts on how to figure out those sketches? You didn't get that far?
No, I wasn't here, so I actually
Okay. Did anybody have any ideas of how to make this make sense? Would you like to share them with me? Anyone? What are we, back in virtual land? Bueller.
tired today.
You're tired? So am I. Come on.
Wait, what?
Huh? There you go. Wait, what? Exactly. And I'm so glad I'm recording all of this so that everybody can hear my class not answer me and not have any idea what I'm talking about. Okay, in the packet, you had a velocity time graph that looked like that. And it asked you to sketch the position time and the acceleration time. Okay? When we think about these x, v, and a graphs, we're constantly thinking about slope, right? The slope of this is this. The slope of that is that, right? So the slope of x is v, the slope of v is a. Yeah? So talk to me about the slope of that v versus t graph that you see, yeah?
It should be the same for all of them.
Yes, so the slope of that v versus t, do you see that that is just a constant non-zero number? So that's going to be what goes on my a graph as a constant non-zero number. Okay? My x versus t graph's a little harder because the slope of my x versus t is my v, and my v is getting bigger and bigger and bigger. So what does that even mean, to have something where the slope gets bigger and bigger? It looks like, right, like a curve like that. It's a parabola, actually. Okay? And so when we think about the slope, we say there, and there, and there, right? And so that slope is getting bigger and bigger, which you see in the v versus t. That value is getting bigger and bigger. Okay? This object right here, can you describe this object? The motion of this object? Okay, it is accelerating. It's speeding up. Yeah, it's a constant acceleration. Right? This is an object that it's speeding up, right? When we look at this. Okay. Let's compare and contrast to this. What if my x versus t looked like that? What do you think, Rocco?
Doesn't it look the same?
You think it's the same? You think v versus t?
No, I think it's like the line, like the. Wait, no, the V is like the straight. Wait, actually, I could go.
Okay. Lauren?
V is a pattern.
Yes, v is flat because the slope of x is v, the slope of v is a, right? So the slope that you see in the x versus t graph is a constant positive value. And so that's what goes on the v versus t graph. Yeah? Matthew?
So the acceleration versus time graph would be.
Correct. The acceleration is 0 because the slope of a flat line, that plateau, is 0, right?
What happened before the
Yeah. Yeah, so we were just looking at that sweet spot stuff. Yeah, good. But remember what acceleration means. It's a change in velocity over time. If the velocity is not changing, there's no acceleration. There's no rise, right? If you're going to do a rise over run. Okay? So this is a constant velocity situation. All right? Woo, that was a lot. Let me stop.